Hi folks, we're going to take a look at this identity that they're asking us to prove. All right, so first thing we have to decide is what side we're going to start manipulating. Since we can't treat this as an equality, we have to prove that it's an equality. So here it's clear that the right-hand side is the one that offers more opportunities for manipulation. So I'm going to start with the right-hand side here. Okay, and the first thing I notice is that I've got sine of 2x, and I've got a sine x in the denominator, so it makes sense to expand this using the double angle formula for sine. And there's just the one double angle formula for sine, so I'm going to write that as 2 sine x cos x. Okay, and of course I still have the sine x in the denominator, and right away I can see that sine x is a factor in both numerator and denominator, so I'm going to be able to cancel that out afterwards. All right. Now this is where we have to be a little more careful because cos 2x has 3 possible options. All right. So what you want to do is you want to look at what's nearby. And I see that it's being divided by a cos x. So I'm going to use the version that only has a cosine x. In fact, I'll do another version of this here just to show you that I can still get to the same answer, just with a different identity. All right, so let's do that here. So this becomes 2 cos squared x minus 1, okay, over cos x. All right, so I know that on this left-hand expression, I can reduce the sine x's since they're both factors. So I'm left with 2 cos x. All right, now what do I do here? All right, do I turn this into a sine squared? Probably not. Since I've got a cosine here. This is where I might look at the other side of the equation, and I notice that I'm going to eventually get to a secant x. And I notice that I have 1 over cosine, which is secant. So this makes me now consider what happens with this division. And I realize that if I divide 2 cos squared by cos, I'm just going to end up with 2 cos x. Exactly what I have here. So sometimes it's not a bad idea to try to foresee what might occur. So what I'm going to do is I'm going to distribute this division to both of those terms in the numerator. But this is where I need to be very careful because I'm subtracting this whole expression. So it's going to be minus that first division. Okay, so let me write it out. 2 cos squared x over cos x. Okay, but then here I have to distribute that minus 1 to the second term. So this is actually going to end up being 1 plus 1 over cos x. Okay, so again, please be very careful with your algebra here. And as we sort of foresaw already, what happens is that one of these cosine factors in the numerator will reduce with the cosine factor in the denominator. So we're left with minus 2 cos x plus 1 over cos x. And so these just subtract to 0. And I'm left with 1 over cos x, which of course is equal to secant of x, which is equal to my left-hand side. Okay. And so there we have it. We have our identity proved. Okay, now just to sort of show you that sometimes you might not necessarily make the best decision in terms of which identity to choose, but you can still get to the same answer. So I'm going to do the same thing here. Okay, but let's see what happens if I choose a different expression for cos 2x and see that I can still get there. I suspect it might take me a couple more steps. So here I'm still going to turn this into 2 sine x cos x, not really much choice there. All right, minus, and let's pick one of them. I don't know, let me pick cos squared over sine squared. Okay, sorry, cos squared minus sine squared. So that's another option for cos 2x. So cos squared x minus sine squared x over cos x. And let's see what happens here. So again, I'm still left with 2 cos x here. All right, and here again, I think I'll distribute this division. So we're left with minus cos squared x over cos x. And here again, remember, this subtraction has to apply to the whole thing. So that's going to end up being plus sine squared x over cos x. All right, so let's see what happens here. I have 2 cos x. Here I have minus. This one of those cos x's is going to reduce with the one in the denominator, so minus cos x. And so now here, well, I'm going to have to make some sort of choice as to what I'm going to do. So let's simplify first. So plus sine squared x over cos x. All right, and so let me simplify. So 2 cos x minus cos x gives me cos x plus sine squared x over cos x. And so now what I can do is bring these two together under one fraction, because let's take a look at what I have on the other side of the equation. Secant of x can be thought of as 1 over cos. So let's see what happens. Let's add using a common denominator. So my common denominator is going to be cos x. So here, this doesn't have a denominator of cos x, so I'm going to multiply that to get cos squared x. And then here I already have a denominator of cos x, so nothing's going to change, plus sine squared x. And this is where I realize, hey, wait a minute, cos squared x plus sine squared x is equal to 1. And lo and behold, I got to the exact same place, okay, which is equal to our left-hand side. So I was still able to solve the identity or prove the identity, but it took an extra 3 steps to get there. Okay, so again, one of the things you want to do is that when you're choosing what identity to use for cos 2x, try to choose the one that matches the other expressions that you have nearby. In this case here, because we were dividing by cos x, it made sense to use 2 cos squared x minus 1. All right, so again, just a quick recap here. When you're determining what side to start, try to choose the one that offers more options for manipulation. Okay, another thing that I want to remind you here is these little algebra mistakes that we have to avoid. You're subtracting this whole expression. So if you're breaking this up, it's minus the first, minus the second, which ended up giving us the addition. So please be careful with things like that. Okay, that's it for this.